Hello all, myself Janil Popat. Let us discuss soil classification. This is video part 3. In previous videos, we have learned different classification systems and different theories. Now, let us understand one thing, that is group index. So, first of all, group index is given by American Association for Road Transport, that is known as AASTO. AASTO has divided the different subgrades. Subgrade means the layer which is most bottom of the roads, right? And according to that strength of that subgrade, the road quality and road upper layers are decided. For that, American standards are showing A1 to A7 different groups. For that grouping, we have to find out group index for any soil. If it is feasible for making a road on that, or we have to work upon that and strengthen it for making a road upon that. To check that, we have to understand the group index. Group index is nothing but a formula given by empirical analysis, and from that we find out the group index value, and from that value we can decide it further. Let us understand group index then. GI group index has a formula 0.2 F minus 35 plus 0.005 F minus 35 into WL minus 40 plus 0.01 F minus 15 and IP minus 10. So this formula is having three things: F, WL and IP. F, that is soil fractions passing through ISC of 75 micron. WL, our liquid limit, and IP, that is plasticity index. So if you have three things, you can find out group index of any soil. Now this long formula has been shortened with ABCD alphabets. Now A, here F minus 35 is known as A. Same with WL minus 40 is known as C. F minus 15 is known as B and IP minus 10 is known as D. Now GI is generally varying between 0 to 20. Now if GI value is very much higher, the quality or the construction material strength will be lower. So if you are having GI 0, it will be very good for construction of road above that. If it is having maximum value, GI is having maximum value, then construction material will be most poor according to AASTO. Maximum value of A and B should be 40 and maximum value of C and D should be 20. So value of A and B cannot go above 40 and C and D cannot go above 20. So this is group index. Let us move forward. Problem number 1. A fine grained soil sample has liquid limit 60% and plastic limit 18%. Classify the soil. Let us solve this. If we write given data here, WL is given as 60%, WP is given as 18%. Now, first of all, to classify this, I have to find out plasticity index, which is known as IP. IP's equation is gap of liquid limit and plastic limit. So liquid limit is 60%, plastic limit is given as 18%. So 60 minus 18 comes out as 42%, which is plasticity index. Now I knew plasticity index. Now it is for fine grained soil. So I have to go with IPA line IS classification. For that I have to find out equation of IPA line or plasticity chart equation, which is 0.73 WL minus 20. Putting WL value as 60, I am getting IP as 29.2%. Now IPA line equation is at 29.2%. Here in this graph, if we see, this line is having value 29.2. So line is coming like here somewhere. And my IP value is coming out as 42%. So in this case, IP value is coming out as 42%. For this, we can clearly see that 42% is greater than 29.2%. For that, WL should be checked. WL is greater than 60%. So if it is above 50, it will be 60% and it will be somewhere here. So if we get our point here, it must be CH, and that is how we can write given soil is CH. CH is clay with high plasticity. So that's it for this problem. Let us move to next problem. Problem 2. The following data is taken from 5 soil samples. So on the site there were 5 soil samples were taken, and now they want to classify the soil. For this we need data. So this table is showing LL and PL data. So LL when it is 25, PL was 15, 45 23, 50 25, 60 35, 80 36. Let us solve this. For solving this, we need to prepare a table as there are 5 soil samples. For that, we don't want to create a complex calculation. We have to keep it simple. That is why we have to prepare a table. You can do it individually also. Here, LL and PL values are written according to problem only. Then I have found out IP, that is plasticity index, WL minus WP. So the gap coming out as 10%, 22%, 25%, 25% again, and 44%. Now I want to find out A-line equation value. According to previous problem, we did same way. So A-line equation value is coming out as 3.65, 18.25, 21.9, 29.2 and 43.8. What is IP A-line equation? 0.73 WL minus 20. According to that, the values are like this. Now I have to decide in all cases if it is coming above or below IP A-line. So let us talk about first case. Here A-line equation is 3.65 and my IP is 10. So it is clearly above that. Here A-line equation is 18.25 and it is 22. So again above. 21.9 and 25 IP. Then it is above. 29.2 and the IP value for this case, that is 25. So it is below IP A-line. Again 43.8 and 44. That is above. Here it should be above. Now moving forward to types of soil. So if it is above, then it will be a CL. Again it will be a CI. Why it is CI? Because the water liquid limit, that is water content at liquid limit, that is in between 35 to 50, that is 45. So it will be CI. Here in the third case, it is having water content at liquid limit, that is 50%. So it is on the edge. So I have to take it is as CI or CH. It can go in both the cases. Now liquid limit is 60% and it is going below. So I have to use MH or OH. And WL is 80 and it is going above. So I have to go with CH, clay with high plasticity. If you do not remember full forms of them, CL, that is clay with low plasticity, CI, that is clay with intermediate plasticity, CH, clay with high plasticity, MH, silt with high plasticity, and OH, that is organic soil with high plasticity. So that's it for problem 2. Let us move to next problem. So going to problem 3, find out the group index for the soil with percentage passing 75 micron ISU, that is 70%. Liquid limit is given as 50% and plastic limit is given as 24%. Now for solution of that, given data can be written as F is equal to 70%, WL, that is 50%, and WP, that is 24%. Now we want to find out group index, right? So we have to find out A, B, C, D. A, B, C, D were like this: A, F minus 35, B, F minus 15, C, WL minus 40, and D is IP minus 10. So F, WL and IP are provided. Putting all the values, I am getting A as 35, B as 55. Now B cannot be maximum, cannot be greater than 40. So I have to take, if B is 55 even, then I have to take B as 40 only, because its maximum value is 40. C is coming out as 10 and D is coming out as 16. Others are in range. So A, B, C, D are found out. GI formula can be put, that is 0.2A plus 0.005AC plus 0.01 BD. So putting all the values in this equation, I can find out GI as 15.15. Problem 4. Percentage passing from 4.75 mm ISU, that is 64%, and percentage passing from 75 micron ISU, that is 6%. Furthermore, uniformity coefficient, that is Cu 7.5, Cc, that is 2.7. Furthermore, plasticity index is 2.5 and we are told to classify the soil. So it is very simple problem, but it needs understanding. So as per IS classification, percentage passing through 75 micron ISU is less than 6%, so which is less than 50%. So first of all, according to IS classification table, we got the idea that is coarse grained soil is this, because it comes under CGS only. Now, furthermore, in CGS, percentage passing through 4.75 mm ISCU, that is 64, that is greater than 50. So it comes on top table, or soil is, we can say soil is sand, right? Now, if it is sand and having value Cu is greater than 6, that is 7.5, and Cc in range of 1 to 3, that is 2.7. So we knew that from that table, this is case of well graded sand, which is SW. So that's it. It is very much easier, but we have to remember all the data learned in this chapter. So that's it for this chapter. We will understand more geotechnical engineering in next videos. Thank you.